Okay, so for today, we're only going to talk about arithmetic, okay, and then on Monday, we're going to do geometric. Even though it says both, we're just going to do half today. So if you read the definition of an arithmetic sequence, it's a sequence of numbers. It's called an arithmetic sequence if the difference of any two consecutive terms is constant. Okay, the difference is called a common difference, or B, right? So basically, once you have both arithmetic and geometric, you have to decide which one it is before, because there's a different formula to use for both, okay? And it's really easy to decide. Either they have a common difference or a common ratio. In other words, to get from one number to the next, you either add, okay, or use addition or subtraction, which is arithmetic, or you have to multiply, okay, which is geometric, okay? So the ones that we're going to do right now are arithmetic. So the way you find D, okay, it depends on which direction you want to go, right? If you want to add, you can go forward that way. But in my opinion, it's easier to go backwards and subtract. This is, in my opinion, the easiest.
So you can do it any way, like
you
there's
can do
no
it.
specific.
Right. So in other words, if you're trying to find D, in other words, they call it the common difference. If you're looking for D, the easiest way, in my opinion, okay, is to take the second term minus the first term. That's the easiest way. Because see, sometimes it's very simple. For example, okay, if you look at number 1, what's the common difference to get from 2 to 6, or from 6 to 10, or 10 to 14? What's the common difference there?
4.
Yeah, and it's very easy to look at. But as the numbers get bigger and different, it does get a little harder, okay? So if you want to find the difference, if you want to see if there is a common difference, you can say, all right, and you go this way. 6 minus 2 equals 4, yes. So the common difference is 4. And when it has a common difference, it's considered arithmetic, okay? So you can test it on each one. 18 minus 4 is 14. 14 minus 4 is 10, right? And 10 minus 4, it works. Or you can go the other way, like I said, by adding. You add 4 every time. Either way, okay? Now let's test this one. I'll give you a second, don't call it out. Try this one. Is it arithmetic? And if so, what's the common difference? Remember your trick. Go this way. So if you do 10 minus 17, 10 minus 17, okay, what do you get? Negative 7. It's okay for the difference to be a negative. It just means that you're subtracting 7 every single time. Check a couple more to make sure, okay? You don't want to be sure they're tricking you, right? You want it to be minus 7 every time, and you can check. 3 minus 7 is negative 4. Negative 4 minus 7 is negative 11, right? And negative 11 minus 7 is negative 18. So the common difference this time is a negative number, and that's fine. In other words, it's what you need to do to jump from one to the other. Okay, now then, when you're talking about arithmetic, okay, the first 4 terms of a sequence and verify that it's arithmetic. So first it wants me to find the first 4 terms, and then I'm asking, is it arithmetic or not? Remember, something is arithmetic if they have a common difference. So if I want to find the first 4 terms, they call this, guys, this is the rule. Okay, this is the rule. In other words, it's kind of like, you used to call it maybe in 6th grade or something, like a little function box, and you'd put a number into the function box and you would perform an operation and a number would come out, right?
Yeah.
Okay, that's what this is. This is the function box. Okay, you're going to, here's your number, right? So if I'm looking for t of 1, if I'm looking for the first number, then I plug a 1 into my function. N is 1. Right? So 3 plus 1/2 is 3/2. You can do 3.5 if you want, it's fine. Now let's find t sub 2. To find the second term, I'm gonna plug in, I'm gonna plug in 2 into my rule, right? So n is right here, so I'm gonna plug in a 2 there. You multiply first, so 6 plus 1/2 is 6.5, or 6.5. Okay, t sub 3, one of the first 4 terms. So 3 times 3 plus 1/2 would be 9.5. You notice a common theme here. And then we're going to do 4, so 3 times 4 plus 1/2 would be 12.5. So there's the first 4 terms. 1, 2, 3, 4, which we did. Then it says, is it arithmetic? Is there a common difference, guys? So the answer is yes, and D is 3. Do y'all see that D is 3? You're jumping 3 every time. If you weren't sure, check. Do 6.5 minus 3.5. You get 3. 9.5 minus 6.5. You get 3. Right? It's easier to go backwards to find the difference. Second term minus the first. All right, the next one, let's try it. It says find the first 4 terms. So we're going to find t sub 1 first. In other words, t sub 1, notice that there is an n here and here. They're the same thing. In other words, if you're finding t sub 1, the first term, you're going to plug in 1 for n. So this becomes 3 minus 7 times 1. Negative 4. Now let's find the second term. Plus you plug 2 in. Remember you multiply first, so it's 3 minus 14. The third term would be 3 minus 7 times 3. So 3 minus 21. And then t sub 4. Here's my first 4 terms, negative 4, negative 11, negative 18, and negative 25. It asked if it's arithmetic. Check. Okay, do negative 11 minus a negative 4, or do negative 18 minus a negative 11. And each time you get what? Be careful. Negative 7. So it does have a common difference. In other words, it is arithmetic, and D is negative 7. The next one. Find the nth term of an arithmetic sequence given to you by this formula. Okay, so this one's a little weird. Let's read it again. Now, you'll notice there's a tiny little n, right? In other words, earlier we said, okay, if I want to find the first term, I plug a 1 in. If I want to find the fifth term, I plug a 5 in. Okay, so in other words, if I'm looking for the third term, it was 9.5. If I was looking for the second term, it was 6.5, right? So this formula actually will find you whatever term you want, okay? If I want to find the 50th term or the 60th term, because what happens, not always is there a rule. You might know the first 3 terms, right? And by knowing the first 3 terms, then you're going to say, okay, if I know the first 3 terms, what's the 50th term, right? If I know the first 5 term, what's the 100th term? Well, rather than adding 7 100 times, it's a lot easier to do what we just did on this, right? We found the rule, and if I wanted to find the 100th term, I would just plug 100 into my little function box, right? This was the rule. I multiplied the number by 3 and I added 1/2. Over here, I multiplied it by negative 7, right? So I did 3 minus negative 7 times n. That's the rule. You can come up with your own rule. If I give you a few of the numbers in the sequence, you can come up with your own rule, okay? So here is some ideas with that. Find the nth term. So t sub n just means any term you're looking for. Okay, the 100th term, the 50th term. So label that, guys, as any term. Any term you are looking for. Right, that's your answer. It just depends on what term you put in. If I put in the fifth term, like for example here, if I put in a 3 for n, I got 9.5. Okay, this is important. Follow this. This will make this easier. Watch. Okay, if I put in right here on this problem, if I put in the third term, I got 9.5, right? So in this little simplistic thing here, if you put in 3, you would have gotten 9.5 over here. That's what it means. Okay? In this formula, I put in 4 and I got 12.5. If I put the fourth term in, the fourth term is what? 12.5. These two kind of go together. Do you see what I mean? If you want the fifth term, you put a 5 there and you do the math, it will give you the fifth term. If you want the 10th term, you put a 10 here, okay? And you do the math, it will give you the 10th term. Does that make sense? Okay, so now then, what do you think T sub 1 would mean? What do you think T sub 1 is? Nobody knows? Want to guess?
The first term.
The first number, yeah. T sub 1 is the first term. Okay, and we already decided what did n stand for. N is actually used here and here. It's a sub n. In other words, like we did earlier, if you want to find T sub 3, if you want to find the third term, you plugged in a 3 for n. Do you see how it's kind of the same? So this n stands for the term number. So the number of terms. And what do you think the D stands for? We've already found D plenty. The common what? Common difference, yeah. Okay, so let's turn the page. Just because we switch pages, I'm going to write that formula we just talked about up here on the top. Okay, so there's the formula. And here's the thing. It says, find the formula or the rule for the nth term of the arithmetic sequence. In other words, this is what this means. 5, 10, 15, 20. What if I asked you for the 100th term? You could get out a sheet of paper and keep going. 25, 30, 35, 40, and count each term until you got to 100, but it would take forever, right? Or you could develop a rule and just plug in. If you want the 100th term, plug in 100. If you want the 20th term, plug in 20, right? So we're going to find the rule, okay? So if we find the rule, we're going to fill this in. All right, so we're going to fill it in. So what is, first of all, let's start with what is D? D equals how much? Is there a D? What's the common difference? 5, excellent. Okay, and then let's just fill in this rule. Okay, since it is a rule, okay, go back to the other page, I want to show you something. Okay, these were rules, weren't they? A rule needs an n in it. Because I need an n, because I want to say, okay, what's the 50th term? You plug in 50. What's the 100th term? You plug in 100, right? The rule needs a variable. Okay, so we're going to try to keep the variable. That's the point of a rule. So I can find any term I want. So let's plug this in. Okay, T sub n. Okay, in other words, any number I want to find equals, what's my first term? 5 plus, okay, I don't know what n is because I don't know what term I'm looking for. I want to write a rule. I want to keep n in my rule. So I'm going to leave this as n minus 1. And what's D? 5. Okay, now your second step, okay, so this is your first step, find D. Your second step is write the rule, and your third step is clean this up. You want to clean it up. In other words, this is too messy. Let's make it look pretty, right? So you're going to say T sub n, yeah, and distribute. Equals 5 plus, 5 times n is 5n, and 5 times negative 1 is negative 5. What happens to the 5 and the negative 5? What do they do?
Cancel.
They cancel. So t sub n equals 5n. And there's your rule. If I want to find the first term, I plug a 1 in, right? So in another color, let me just kind of show you what I'm talking about. So if I wanted to find t sub 1, I would say, okay, 5 times 1, 5. If I want to find the third term, I would say, well, what's t sub 3? So I plug a 3 in for n, 15. That's why the rule has the n in it. Okay? Let's try this one now. Find the rule. There's 3 steps. Remember, I gave you 3 steps. 1, 2, 3. Okay, let's start with the first step. The first step is to find the common difference if there is one. All right? So to find the common difference, you're going to do negative 29 minus a negative 21. Remember, you go this way. What's the common difference? Excellent. Negative 8. Okay? So now then that was step 1. You found the common difference. Step 2, let's use the formula and write a rule. I want to keep a variable. It's a rule. Okay? If there's no variable, what's the point in using a rule? Right? It's like that little function that goes in your little pretty function box. Plug in a 3, plug in a 5, make a rule for your little function box. Right? That's what you're doing here. So I don't know t sub n because I don't know the answer. Equals, what's my first number in here? Negative 21 plus, I want to keep in, minus 1 times my common difference. Now be careful. And that's minus, you better put parentheses around it so you don't actually think it's subtract, right? The rule stands for n minus 1 times d. So that's step 2. Step 3 is to do what to it? Clean it up, make it look better. So t sub n equals negative 21, and I'm going to distribute this. Negative 8n plus 8. Always put the variable first, so negative 8n, and then combine these. Negative 21 plus 8.
Negative 13.
Mm-hmm. Yay. Okay, we're getting closer. We're only going to 10. We could do the whole packet if you want.
Yeah.
I'm just making sure you're all complaining. All right, number 7. Find the indicated term of the arithmetic sequence. Okay, so here's the weird part about this one. Okay, I'm looking for the which term, guys?
56.
The 56th term. Did it give me a rule?
No.
No, but I kind of have a guideline. Right, my guideline for arithmetic, that's important, because what's going to change for geometric, there's a different rule for geometric. So for an arithmetic sequence, it's t sub n equals t sub 1 plus n minus 1 d. Right, that's my formula I'm going to use every time for arithmetic sequence. So if I'm looking for the 56th term, let's see if we can use this formula and find it. So what do you think t sub n is? Do I know?
56.
It's not 56.
No, we don't.
We don't know.
440.
I'm looking for the 56th term, right? T sub 56. In other words, what is the 56th term? It doesn't equal 56. I want to keep going. I want to say 2, 10, 18, 26, 56 times. Do you think it's going to be 56?
No.
No, it's the 56th term.
So we find the rule.
Right, I'm looking for the 56. I'm looking for, like go back to here. When I looked for the second term, the answer wasn't 2. No, I plugged 2 in and got the second term. When I was looking for the fourth term wasn't 4, right? I plugged 4 in. So go back and think about that for a second. I want to know what is the 56th term. So I want t sub 56 equals, what's the first term? Let's plug it in and use this. 2 plus, what does in stand for? Which term am I looking for?
56.
How many times do I need to make the jump? 56. And what's my common difference?
8.
How do I get here? 10 minus 2 is what? 8. My common difference plus u is 8. Don't forget that's a times right there. I don't have a variable anymore, just type straight in your calculator.
Same.
What's the 56th term?
414.
Be sure to write it like that. T sub 56, in other words, the 56th term is 442.
Same.
Okay, I'm gonna give you a minute to try 8. You try 8. See what you know. I'm looking for the 41st term. Okay, so if you're looking for the 41st term, this formula finds it for you. You take the first term, you start at 19, and you add, and basically, guys, this is what it's saying. It's saying you're gonna add 41 minus 40, 41 minus 1, and you're gonna multiply that, which is actually 40. In other words, you're gonna start at 19, and you're gonna multiply 40, the common difference. In other words, you wanna take 19 and add the common difference 40 times. It'll get you there. That's what how it's working. What is the common difference? What is 8 minus 19?
11.
So the common difference is negative 11. You have to go backwards. Right? How do you get from 19 to 8? You subtract 11.
What difference?
Okay? So you're going to multiply by negative 11. So t sub 41, the 41st term, is negative 421. Okay, we have 2 more. All right, I'm going to write down the formula again, because we're continuing to use that formula. So t sub n equals t sub 1 plus n minus 1 times the common difference. That's your formula. And the question says, this is a good question you might have been asked like as a little bitty kid, like in 3rd or 4th grade, on a test question, and the teacher, like a project test question, the teacher would say, oh, how many numbers are there between here and here? And that poor little 3rd grader literally would just write them all down and take forever and count them all up, right? There's a formula for that, okay? All right, so, but it's trying to get the kid to show like a little bit of reasoning and counting and things like that. But reality, no, I just look up the formula and plug it in, okay? There's a formula. And so how many terms are there in this sequence? And that's the question. How many terms are there? Now my question to you then is, if I'm looking at this formula, what variable am I actually looking for? When I want to know how many terms there are. Do I know the last term?
Yeah.
I know the nth term. Do I know the first term?
Mm-hmm.
Can I find the common difference?
Mm.
Yeah, so what do you think the term is? Which variable in here, if you were just going to guess, which variable am I looking for? In. This is saying what is in. Okay? So in other words, I know the last term number is 2. I just don't know what term number it is. Is it the 50th? Is it the 4th? Right? So t sub n, in other words, this is the way you look at this is the last term. The last term is 2. My first term is 178. Take good notes on this part. Plus n minus 1. I don't know. I know 2 is the last term. I just don't know what term number it is. I don't know if it's the 50th term or the 40th term. What's my common difference? Be careful.
Negative.
Right, -8. So what variable am I looking for? N. I want to know how many terms there are. If I start at 178 and I end at 2, how many jumps did I make? That's what I'm looking for. So I think first you should distribute. So 2 equals 178 minus 8n plus 8. Watch your math there. Now your algebra skills are going to come in handy, right? Now, the next thing I think you should do is combine these on the right. Now be careful. When they are on the same side, you add them. So 178, okay, plus 8. So now I have when they're on the same side, you add them. When you move them across, that's when you do the opposite. So minus 186. So now you have negative 184 equals 8n. When you divide in negative 8n, I'm sorry. N is what?
23.
So there were 23 terms, guys. This is the most important part, is for you to realize when I'm asking you how many terms, you're looking for n. I highlighted that to help you remember. Okay, the last one. Yay. Last one. The problem says, find the number of multiples of 7. In other words, how many multiples of 7? What are multiples of 7, guys? 7, 14, right? 21, 28, and so forth, 35. I'm saying how many multiples of 7, okay, are going to be between 30 and 100? If I'm looking for find the number of multiples, what letter do you think I'm looking for again? How many multiples are there? How many terms are there? What letter is this? What variable? N. Highlight that. Okay, well, to use our formula says that we need the first term and the last term. Here's the problem. Okay, is 30 the first multiple of 7? No. Okay, no. If I'm looking at numbers, now pay attention. All right, guys, so if you've tuned out, tune back in. This is probably the hardest problem. So take such good notes that when you get ready to try this problem on your own, you can see what you did. Okay, so here we go. I'm talking about a window of numbers between 30 and 300. But all I care about are multiples of 7. So what's the first multiple of 7 between 30 and 300? 35. Okay, so what you're going to do is you're going to say this is a little window, but 30 is not really my first multiple of 7. 35 is. Now, to find the last multiple, it's a little trickier. Get your calculator out for me. And to find the last one, you can draw a little arrow to see what you did so you don't forget. Take 300 and divide by 7. Tell me what you got. 42 point what? 42.8. That means 7 fits in 42 times. Will it fit in 43? No. So you take how many times it fit in. That's why I'm telling you to write good notes here. 42, that's the most it'll fit. Okay, and you do 42 times 7 and tell me what you get. 294, right? Because watch, 43 times 7 would give you too many. It'd give you 301. Right? So 43 won't fit in. So let me show you again how to find it. Watch with your eyes. If I want to know how many 7s fit in here, I did 300 divided by 7. I got 42.8. Correct? So 42 fit in perfectly. So I said, okay, well, how many is that? 42 times 7. So then that's my next number, 294. And those are the numbers used for start and end. because that's all you care about, multiples of 7. Okay, so now let's fill it in trying to find n. So t sub n, what am I going to use there? That's the last, no, 7 is d. That's the last term, 294. It's usually your last term, t sub n. Equals your first term, 35. Plus, okay, now watch, guys, if this confuses you. In other words, I'm saying 294 is what term? These go together, right? Because if I plugged in a number, I get this. If I plug in 5, I get the 5th term. If I plug in 7, I get the 7th term. I'm saying 294 is what term number? Do you see how they go together?
Mm-hmm.
Minus 1, what's your common difference, guys? 7. Put parentheses around it so you remember to multiply. So 294 equals 35 plus 7n minus 7. Okay, these are on the same side, so put them together. So 294 equals 28 plus 7n. Subtract 28 from both sides, and then divide by 7. So there are 38 multiples of 7 between 30 and 300. So in other words, let me explain something to you. That meant that 294 is the 38th multiple, right? I went from 35 to 294, so 294 is the 38th multiple. Okay, that's it for arithmetic sequences. Keep these notes, we'll need them for tomorrow, or Friday, sorry. No.
Monday.